Good morning, students. Welcome to the online learning session of Brilliant Public School. Topic for the day is three-dimensional geometry for class 11 mathematics. First of all, let us see how we are going to make a three-dimensional plane. In three dimensions, the coordinate axes of a rectangular Cartesian coordinate system are three mutually perpendicular lines, and these axes are called as x, y and z axes respectively. In the figure you can see the three axes x, y, z intersect each other at a point O, forming a three-dimensional plane. The three axes intersect each other at a point 0, 0, 0 called as origin and are mutually perpendicular to each other. Now these three axes determines three planes by the pair of axes and are the coordinate planes, which are called as xy plane, yz plane and zx plane respectively. You can see very clear in the figure, the coordinate planes divide the space into 8 octants. You could see very clearly the three planes which are meeting each other at a point origin are dividing the space into 8 octants. Now the coordinates of the points on x-axis is of the form of x 0 0, y-axis is of the form 0 y 0, z-axis is of the form 0 0 z. Now if the point lies on xy plane, then its coordinates are of the form xy 0, yz plane is of the form 0 yz, and the point lies in zx plane, then the coordinates are written in the form of xoz. Now these coordinates will have different signs in the octants as we have learned for the two-dimensional geometry. So let us see what is it for the three-dimensional geometry. The 8 octants with respect to x, y, z coordinates. In the table you can see that we always start with the first quadrant with all the three coordinates as positive. In second, we go on negative x-axis and positive y and positive z. Similarly, you can see it for all the 8 quadrants that how the sign changes for x, y and z coordinates respectively. Now, we already have learned how to find the distance between the 2 points in the two-dimensional plane. Similarly, we extend that concept to a three-dimensional plane, and you can see very clearly 1/3 coordinate has been introduced while representing the point. So let us consider point P, x1, y1, z1 and q, x2, y2, z2. So the distance between these 2 points is given by under root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Now distance of a point P, x, y, z from the origin will be given by OP is equals to under root of x square plus y square plus z square. Now let us consider the internal and external division of a line segment. You have already studied this for two-dimensional geometry. So in the same manner, we are extending the same concept to three-dimensional geometry where one coordinate is increased. So you could see C is the point xyz which is dividing the line segment x1, y1, z1 with point A and with point B x2, y2, z2. Now let us consider that it divides internally and externally in the ratio m is to n. So the coordinate of the point R which divide the line segment joining 2 points P x1 y1 z1 and Q x2 y2 z2 internally in the ratio m is to n are given by, you can see it very clearly, mx2 plus nx1 upon m plus n. Similarly for y and z, and if we talk about external division, it is mx2 minus nx1 upon m minus n, and same for the y and z coordinates respectively. Now, to find the coordinates of a centroid of a triangle whose vertices are known. Suppose the vertices of the triangles are given by x1, y1, z1, x2, y2, z2 and x3, y3, z3 respectively. Then the coordinates of the centroid of that triangle are given by x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3 and z1 plus z2 plus z3 upon 3. So the concepts which are taken up in this chapter three-dimensional geometry for 11th class are three-dimensional plane, the knowledge of octants, how to calculate the distance between 2 points in a 3D plane, section formula with internal and external division, and how to find the centroid of a triangle when its three vertices are known. So these are all concepts which are taken up in the chapter three-dimensional geometry for class 11. Keep learning, children. Thank you very much.